what I'd like to do today is talk about relevance in a somewhat critical eye. And since we're a cozy enough audience, feel free to interrupt at any time. If we go too far off track, I might push things till after the end for questions and answers. So just to introduce myself, my name is Daniel Tunkelang. I'm the chief scientist and a co-founder of Endeca. My background, I did my undergraduate at MIT in math and computer science, 1863 for folks for the numbers, and my PhD at CMU. My background is actually not in information retrieval per se. I really studied more visualization of information and kind of came sideways into the IR field. I actually think that in some ways perhaps gives me the advantage of an outsider in questioning some of the canonical ideas of the IR field. Obviously, this is not a sales or recruiting talk for Endeca, but for those of you not familiar with what we do, we're an enterprise search and information access company, and a lot of the ideas in this talk, I would say, are sort of philosophically the foundation of our approach. So, the overview, I'm going to ask us to reconsider relevance. Then the least I can do is define what I mean by relevance. So I will do that and then offer a critique as well as an exploration of alternatives, because it's not enough to knock something down. We have to offer something constructive. And by the way, the title of this talk, Reconsidering Relevance, is actually it's an allusion to a paper by Tefko Saracevic, who's a library scientist at Rutgers. He wrote a paper called Relevance Reconsidered. He actually wrote that, I think, about 25 years ago. So it gives you a sense of the amount of time people have been thinking about this. I highly recommend one of his lectures, the 2007 Lazaro lecture. It's available on video. If you like this talk, you will love his. He's a much better speaker. So let's first set the stage. Now, I know that I will never be allowed in the Google cafeteria after this, but I actually want to offer a comparison that I think has some merit, and I actually don't even think is particularly derogatory, which is between Google and McDonald's. Now, these are obviously two of the iconic industries. I'd like to say McDonald's of the 20th century, Google of the 21st. Remarkably similar taglines, even to the point that the main competitors of both have interestingly similar approaches. Burger King's with have it your way, and Yahoo actually doing something remarkably similar with its boss, build your own search engine. Sort of the, well, if we can't win on the default, let's offer a nonconformist alternative. Now, the success of both of these companies is what people in the sort of the MBA literature, folks like Deming in the Total Quality Management School, would say is scale orchestration. Right? It's a triumph of process. But there's a dark side. Now, I'm not claiming that Google is doing anything as horrible to our bodies as what apparently an overdose of McDonald's might do to somebody who eats it nonstop for a month. But there actually have been people questioning whether precisely the simplicity, if you will, the prefab experience of Google is making us stupid. This is a Nick Carr article in The Atlantic that drew a lot of attention. Now, okay, it's important to not just look at what people in the press or people who can come up with cute slides might have to say. Users are ultimately what matter. And if you look at users, specifically, not just users of web search in general, but specifically Google's, these numbers are incredible, in the high 80s. I mean, this is the most satisfied user community I think you'll find for a business, especially one that caters to such a global audience. So why, if it ain't broke, why try to fix it? And there's an interesting observation. You can easily find this online and on the blog of the person who wrote it. But what this guy John said was that, look, search on the internet is a solved problem. I believe Marissa Mayer said something similar, although she capped it at 90% solved. And his complaint was about search in the enterprise. Now, I'm not actually here to talk about the difference between enterprise search and web search. We can do that another time. I actually think it's the wrong way to look at what John was after here. The real issue is that there's a notion of search on the internet as one kind of problem, and search in the enterprise is a different kind of problem. Perhaps that notion isn't even made explicit, so people assume it's a question of the domains. But it's actually that there are different kinds of information-seeking problems involved. Now, let's see also what this has to do with relevance. The best way to do this is with some examples. So let's look at some easy and hard information-seeking problems. And I'm using examples that I hope will be clear as not being some kinds of corner cases that, we could solve 99% of the problems. Those ones aren't ones that people care about. I think these are real problems, and incidentally, ones that people are able to solve. It's just that they don't solve them in a relevance-centric way. So where can I buy Ender in Exile? That's pretty easy, right? I would hope that if I type Ender in Exile into Google, I find it within seconds. And it's just a matter of who's done the best search engine optimization, perhaps, to get their copy to me. No problem. But let's say I'm taking a vacation, which I do every few years, and I want a good novel to read on the beach. It's a real problem. It's not clear how I solve that. I mean, I know actually the way I would solve that is by asking friends, right? But it's certainly not something where I type good novel to read on the beach and expect some combination of NLP and knowledge of all my past behavior to certainly crank out that, hey, Orson Scott Card wrote a new book. You should read it. Taking ones that are a bit more technical, finding a proof that sorting with only access to a binary comparator is n log n, that's pretty easy. Anybody who's trying to cheat on their algorithms problem sets can probably find that one, again, in seconds. But let's look at a problem that's actually similar enough. I have a partially ordered set and a comparator, and I'd like an efficient algorithm to solve it. This is a legitimate one, and in fact, I don't know if you guys are still interviewing lots of engineers, but I welcome you to use this one as an interview question. I tried to look up that answer just like I looked up the one for the previous one. And it took me several hours to realize that I wasn't getting anywhere with it. So this gives you, and the reason, as it turns out, is that it's not a neatly solved question for which somebody has written a document to answer it. But here you have two questions. One is easy, one is hard. You can't tell from looking at the form very clearly that one is going to be easier or harder, and yet the difference is there. So these are, there's a feeling of easier and harder information-seeking problems. And the easy ones, the relevance-centric paradigm works quite well for. The harder ones, it doesn't. So with that as a context, let's actually try to get a working definition of relevance, or at least something that we can get a shared understanding of. Now, I alluded earlier that there's a history to relevance as a field. And it's about 50 or 60 years old to think of relevance in information retrieval. One of the earliest folks to work on it was William Goffman. He was actually I believe he's considered a mathematical information scientist was the title. And he made an observation which is surely uncontroversial to most people, which is that relevance is a way of relating queries to documents. That's the first part. In fact, that is how it's defined by most folks. But the second part is one that I think a lot of people overlook, which is that relation isn't enough. And he goes on, and there's a literature that runs with this. And again, I recommend Tefko Saracevic or Stefano Mazzaro for giving more of the, looking at relevance as something as a work in progress as opposed to a function to be optimized. Now, I decided that it would be a good idea not to come up with all of my own definitions for standard IR concepts. So let's borrow a few from what I think is the most standard textbook in the field, which is Abaisa Yates and Rivera Neto's A Modern Information Retrieval. So IR, I'd say actually they have a somewhat conservative definition. It's basically retrieval of text documents. But I don't think there's anything in their definition that is necessarily restricted to text, so that's fine. The more important part is that there is a presumption of user information needs. So let's dive into that. And there, they have actually what you might think of as a peculiar definition, which is that a user information need is a natural language description of the informational need of a user. Now, that's a little bit circular, but you can take that up with Ricardo. The important part there is that they're stuck because typically you're using these definitions operationally to evaluate information retrieval systems. So you can't just say that a need is something that exists in the ether or in someone's head. Instead, they model these as text descriptions. But can live with that. The important piece is, of course, that there's also a notion of a query. And a query is an expression of that information need, which is in a language provided by an information system. In the case of Google, obviously, it's a collection of words, or perhaps in the advanced search, there's a little bit more going on to structure that query. Now, interestingly, that glossary didn't have relevance in it, which I thought was a little bit odd, but it's implicit. Because when you define relevance in information retrieval, what you actually do is to define an information retrieval model, which is, exactly as Goffman put it, is a function that, given a query, in some of the more sort of purist IR, assigns a binary value to each document. Either it is relevant to that query or not. And actually, more carefully, it's relevant to the information need or not. Because if you have this, of course, you can do batch testing. You can say, here's the information need. Here are the documents I know are relevant. I take a system. How do I evaluate it? I look at how many of the documents it got back that it was supposed to, and what fraction were bad. You get precision and recall. And that's hunky-dory, and you get lots of papers in hcir if you can keep improving on this. Now, once you have such a system, you can use it. And this shouldn't be all that surprising, right? I have some information need, and let's dispense with this notion that we have a natural language representation in our heads. That's kind of not too important. But somehow I translate that into a query. Then I send it to the pigeons. I hope all of you are familiar with PigeonRank, since I believe it was developed here on April 1st of 2004. And the pigeons use their various algorithms. These ones are pretty smart. They've learned about TF-IDF and PageRank. For any of you who haven't, I actually recommend modern information retrieval as a text. And finally, they present a set of results, presumably ranked in either the probability of relevance, or if you have sort of some notion of the amount of relevance, you can actually weigh that in as well. And then you pick one. And in sort of Monty Hall, let's make a deal style, you open your result and you hope that it's not a goat. Now, great. Seems like a reasonable model. What's wrong with it? Well, we have some communication problems in this nice little flow. I mean, the first thing is that information needs, even the natural language representations, and they're long. I don't know how many of you are familiar with Trek, but I mean, I look at these things and I think, who even comes up with these? They can be 20, 30 words. As is famously quoted by Googlers and others, the average query length, last I heard, was 1.8 words. Let's even round it up to 2, 3. But clearly, the amount of information that a 2 or 3 word query can bear is nowhere near as rich as what might be in someone's head. Natural language, people have tried it. Apparently, you can sell a company for $100 million if you can generate enough hype about it. But it hasn't really taken, except in some very limited cases like call centers, where people are speaking, it can make some kind of sense, perhaps to convert it. Telepathy, it's actually not a horrible idea. And for any CMU alums here, at CMU, they're actually researching telepathy as an interface, but it's not quite ready for prime time. So that's one problem. Then the next stage. Well, the pigeons might be smart, but they're not going to be perfect. And these IR models they're only as good in theory as the ability to consider relevance to an information need as a function of the query, which, let's remember, is an expression of that information need in the first place. And we also have cumulative error now. So in this sort of game of telephone, things are getting, going from bad to worse potentially. And then finally, the notion that simply you get back a set of results and select from them one at a time, it's a bit inefficient because obviously you're getting a small selection of possibilities of the ways it's interpreted. You're going to select from what's put in front of you. And if you don't see what's there, it's not clear what you do next. You might try to read what's there, learn from it, but essentially it's try again. There's not much of a backup plan. And I like to pull this out as an example, and it's remarkably resilient and works very well for information retrieval conferences. When I look up IR, I'm thinking of information retrieval. I guess a lot of people aren't. There are a lot of IRs out there. But, and this is beautiful and maybe even meets the needs of, I suppose, 20, 30, 50% of the population. It's hard for me to know. I don't have the stats. You guys do, but I doubt you'll share them. But it doesn't actually tell me what to do. Now, of course, I have a brain and I realize, oh, maybe I should type it all out. But this gives you some sense that when things go wrong, the interface hasn't helped me. And relevance obviously is subjective. I mean, you might be that over some averaging, most people who type in IR would be satisfied with one of these. But it's a little bit unsatisfying. And let's take, you could say, well, that was a trick one because I took a deliberately ambiguous abbreviation. Fine. Search engines. Now, this is something that, at least by my understanding, Google is really good at stuff involving search engines. This list of results, and frankly, even the top ads, I mean, maybe people have learned that buying AdWords for search engines is a strange thing, but it's not very informative. It's not bad, actually, in the sense that probably that Wikipedia entry for web search engines is a good place to look. I'm surprised it's not the top result. But this is not giving me a sense of the information that is available about search engines. I wanted to get at here that the communication channel of a ranked list is, at best, okay. And the saving grace here is, incidentally, that Wikipedia has done a great job of organizing the information here. So if you can find that, you're probably in the clear. But good luck if you're looking for something like this that isn't. So sort of summing up what's wrong with the approach, it assumes that you know what you want. It assumes you know how to say what you want. It assumes that what you say will then be interpreted by an IR model that you can trust, that the answer is in a single document of what you're looking for. And so that's implicit in this notion of returning a list of documents ranked as your results. And finally, that you're optimizing for doing this in one shot, because if you have to do it again, it's almost like starting from scratch. So can we do better? And as I'm looking forward to Screaming Horde saying in a few weeks, yes, we can. So, well, I have to actually propose the change we can believe in. So what are the alternatives? Well, a few years ago, Gary Marcianini, who's a professor of library and information science, and I believe also of computer science at University of North Carolina, gave some lectures called Towards Human-Computer Information Retrieval. And he looked at the work that had been done in search and more generally in what's called information seeking. The library scientists have slightly different terms for what most of us end up calling search. And said, look, the problem is really simple. We shouldn't be having the machine try to read people's minds. I mean, we don't do that as people, and we're not even necessarily self-aware enough to know what we want. So let's not be in the business of having the machine's primary responsibility be to guess the user's intent. Or maybe let's do as well as we can there, but then let's optimize for the communication between the human and the computer. And the second part's important too, which is that we should not just ask from computers and from search engines what they can do for us, but ask users what they can do to help themselves find what they're looking for. Let's make this a two-way street. And so we want to ensure that if users are able to put more effort in, they're rewarded for that effort. Which, to put it a different way, for anybody who's seen the Charlton Heston movie Soylent Green, where at the end he discovers that what's in the food supply, it's people. And I want to take a very concrete use case from a few months ago that illustrates what an HCIR experience is like. So a colleague of mine had run into this guy, Steve Pollitt, and said, hey, this looks like stuff you should be looking at. And so I said, sure, I'll check it out. And, I like Google. It's my, until recently, actually, is my primary search engine. And so I Googled him. Found him on LinkedIn. Turns out that's a different Steve Pollitt. The OCLC one is right, but it didn't really get me very far. Wasn't that helpful. I said, well, okay, the guy told me it's some kind of research thing, so I'm using the wrong interface. Let's try Google Scholar. Now, that does better. I'm finding a couple of papers by Steve Pollitt. Yeah, document retrieval. This sounds more up my alley. The glycoprotein natriuretic peptides, sorry, I don't speak organic chemistry, different Pollitt. But that already raises some of the problem that we saw before, right? We have an ambiguous name. So I guess I could try, refining my query, thinking Steve Pollitt, computer science, quote him, AS Pollitt, S Pollitt. I decided actually, let me try something else. At the University of Massachusetts, they have something called REXA. That's essentially, and for those not familiar with it, the Center for Intelligent Information Retrieval at UMass Amherst is an amazing source of lots of IR goodness, such as the involvement in the lemur and injury toolkits. I believe you guys have hired a bunch of their graduates, actually. Well, what's nice here is that even though it may be a ranked list, I at least was able to get, that's that Steve Pollitt I'm looking for, and hone in on his documents. This is an improvement, and a significant one, because, he hasn't lived that long, and he actually died last year, but I could go through his writings. That's better, although, honestly, I was hoping for something a little bit better than reading everything he'd written just to find out kind of what he was up to. So this is an interface that I designed with some folks at Endeca in collaboration with the Association for Computing Machinery. We've been working with them with their digital library. How many folks are familiar with the ACM digital library? Okay, so most of you. So it's all computer science documents, similar in that sense to REXA. But what's nice about the ACM documents, to the extent possible, they demand that their authors actually tag documents with what they're about. The instructions are, what would you want somebody to find in an index? If you imagine, back when people used books and indexes, I guess people still do that sometimes, to look things up, how would you tag it? Now, when we first started working with them, we said, this is going to be great because everybody's tagged their documents. And I think we all know that it's a lot of effort to get people to tag documents. So this gives us a leg up in making this kind of more exploratory interface possible. But we were wrong, because it turns out that authors, as much as they know about their documents, don't tag them in the way that other people would want to find them. They have a tunnel vision, and their tagging was very sparse. However, there's wisdom in crowds. If I could borrow a quote from Peter Norvig, more data versus better algorithms. Well, we needed the algorithms, but the data certainly helped. So we were able to basically bootstrap on the author's vocabulary collectively to generate the vocabulary that we needed, and then we're actually able to tag other documents by text mining for that vocabulary in them. You could actually read this. This is a paper we presented at the second workshop on human-computer information retrieval this past year now, 2008. It's online. But immediately we see what Pollitt is about when we look him up. And I looked up just Pollitt because we don't have any support for like, naming variation here. And we see search, information retrieval, other things. And I said, great. Let me actually refine to just the documents tagged that way. And so now we see Pollitt and information retrieval. And I see refinement as one of the tags. And I say, OK, that's really up my alley. Because if there's one thing that I'm concerned with, certainly at Endeca, it's interfaces that support refinement in the information retrieval process. So I keep going. And in fact, at this point, Pollitt's great. But I'm interested more generally in who else has worked on information retrieval and refinement. I mean, I might not have realized that there was this wealth of things out there when I got in. But if you're going to show me stuff that I want, I'm going to dive into this. And it's kind of a rapid walkthrough of it. But what I want to make clear here is that my information need changed. The system helped me with something more than ranked lists. It supported exploration by giving me directions to look in and worked with me. Now, I know that there's a lot of skepticism about more complicated interfaces than search. But I hope it's clear here that there's value that I got from this to a real information need that I could not have gotten if all I could do was repeatedly search and get back ranked lists. Now, with this as sort of a concrete example, let's see what this ends up looking like in a more technical perspective. I'd say that the earliest work that you could think of as HCIR-ish is the scatter-gather work done at Xerox PARC. I think it's in the early 90s by, God, I'm actually blanking on the names, and I'd like to give credit where credit is due. And that would be to Doug Cutting, who I believe is now at Yahoo, David Karger, Jan Peterson, and John Tukey. And they started from a premise proposed by Keith Van Wisbergen, who's one of the sort of founding fathers of IR. And they said that basically documents that are correspond to the same information need should be grouped together. So well, let's, instead of just trying to say, well, let's hope that when people put in a query, all the documents come back together, let's cluster them. Now, 15 years after the fact, this may not seem all that novel, but this was a big deal. This was really, I think, the first work on document clustering. And here you see a query for star, and the documents are first clustered based on inter-document similarity, and then they take those document clusters and they try to find the most frequent or information-bearing terms within them. And it's not bad, right? You get, for star, you get stuff related to the Star-Spangled Banner. You get Hollywood stars, astronomic stars, kind of the flora and fauna category. This was a nice step. Now, the problem with clustering, though, is that it doesn't actually communicate as well as you'd like. The document similarities are somewhat opaque. I mean, you might be able to explain them by saying, look, we took this bag of words, they're two vectors, we computed the cosine, and ta-da, the aristocrats. But users don't like this. And it's a real problem. It's the reason, I think, that clustering-oriented interfaces have not taken off. It's not so much that they're not good enough as that they don't fail very gently. Faceted search, on the other hand, has done somewhat better. Just a quick show of hands. Folks familiar with faceted search? Smaller set, so I'll explain it. And forgive me those who are bored. Back, I think, it's quite 100 years ago, there's an Indian librarian, Ranganathan, who had looked at the way that libraries are being organized using taxonomies. right? Those are familiar, tree-oriented categories, and said, this is really bad because there may be multiple ways to organize things. And you want to think not in terms of just one hierarchy, but multiple ways of categorizing things. He took this a little bit further than I think was appropriate by actually thinking there was a canonical set of these facets for all information in the world, so that you could basically assign any fact or any piece of information kind of a point in this 5-dimensional space. Perhaps because of that rigidity, he was not able to get this system to supplant the Dewey Decimal one, although he's still revered, I think, as one of the greatest librarians historically and particularly from India. But the idea of faceted classification as opposed to taxonomic classification did start to take off more generally. In fact, Steve Pollard, whom I was talking about before, proposed something called view-based searching, which is essentially a form of this faceted view. But I think more than anyone else, Marty Hurst at UC Berkeley with the Flamenco project put faceted search on the map. What you see here are, this is a prototype application they developed for architecture. You do a search, which is a full-text search for, in this case, Gary, and it allows you to further refine by the facet of people, periods, locations, structure types. And the idea is pretty simple. You're able to progressively refine your query using the different ways that make sense to narrow. And one of the nice things about Marty's work is that she does lots of user studies. And a lot of people believed very strongly that people love search, they hate navigation, search is more efficient, navigation never works. And she actually, using this data set, did a bunch of use cases and found consistently that people did better on this style of an interface, even though it was less familiar to them. And it's not like they were being bribed to prefer it as well. So this was a big deal. Now, you might wonder, given her success, why aren't we seeing faceted search everywhere? Well, actually, we are seeing it in a bunch more places. We're seeing it, I think at this point, almost everyone, frankly, except for Google Product Search, is using faceted search in e-commerce. I'm thrilled that a lot of them are Adeka's customers, but a lot of them aren't. At this point, it's the norm. You see it on Amazon. You see it on eBay. Now, the challenges, though, end up being that the original faceted search model assumed that you simply showed all of the facets and all of the values that were available with a little bit of smarts about it. You wouldn't show a value that led to no results, but that was about the extent of it. Now, that breaks down. It turns out there are too many facets. There are too many facet values. And those first two problems are hard enough. But then the third problem is actually that, the folks saying that people don't like complex interfaces, there's some point to that. Sometimes it is easy to figure out what the user wants. In fact, sometimes it may not be easy to figure it out, but faceted refinement is not the right way to figure it out, as you guys are surely familiar with from things like did you mean. So just interacting with users doesn't necessarily mean that you want to use faceted refinement. Probably the last one is the one that people get most hung up on, which is that this is great, but how do I tag everything? Now, I hope the example I showed with the ACM data shows that you can at least semi-automate this process. And I'll show an example later which does even more of that. Now, which ones to show? This is Home Depot, an Adeka site. And if you're looking for microwaves, you see things like the microwave capacity, the wattage, the color, or the finish. If you're looking for ceiling fans, you see color finish still applies, but you see things like whether there's a remote, lighting, and fan style. In the Home Depot's case, I believe it's done editorially, or through some they've decided whether through explicit or implicit selection when facets come up. There are other ways to do this, right? You can use information measures to decide, at this point, the facet has sufficient coverage or sufficient entropy that it's worth using. And this turns out to be critical because the number of facets, even in a relatively simple e-commerce site, can be far more than you would want to show to users. And let alone if you're looking at something like, for example, a manufacturing application where almost every kind of part has its own facets, some overlapping. So it is important to use some kind of measures to favor the facets. As I said, coverage, information measures, these do quite well. The thing to keep in mind, of course, is that that happens behind the scene. There's still transparency as to what these things mean when they're available. Now, the other thing I want to focus on, I'm not going to talk about which values to show, but rather when to use faceted search. And there's a bit of a debate in the faceted search community as to whether faceted refinement versus clarification using facets mean the same thing. Now, when I say there's a debate, I mean I'm perhaps blowing it out of proportion. I mean folks like me, Sue Dumais at Microsoft, Marty Hurst at Berkeley. But let me explain what I'm after here. The way that faceted search is typically done, and for those of you who've seen it, and perhaps now that you know what it's called, recognize it, you do a search that's full text. You get back a bunch of results. You can slice and dice it. But some queries aren't as good as others. And you may have a query that comes back with a bunch of, to put it technically, crap. That is, there's really nothing coherently holding the set together. And faceted search inherently is a set retrieval approach, not a ranked retrieval approach. You get back anything that matches your set and matches your expression that you used. In the case of a query, it's like looking at the about 1 million documents that came back, not just the top 10. Otherwise, there wouldn't be much point in refining it. But if that set's all over the map, suggesting to people that they can refine by brand or price or what have you is kind of silly. They're not there yet. They've made a query that's ambiguous. You first want to clarify their intention. You want to go from something that is ambiguous to something that may be broad but is not ambiguous. So here I do, admittedly, a toy query, but hopefully one that communicates the point of it. I do a query for steamer. Well, it turns out that the system is in no position to know whether I want to be steaming mussels or steaming mussel shirts. Right? This is a classic case up there with Java and Jaguar, and I forget the other classical list, but this one happens to be one on Home Depot. So what do? We recognize that just from the query text itself, when we say, aha, let's, instead of doing full text search, do what used to be called category search. We consider it dimension search. It's more because we're looking in the space of facets, but you get the point. This is the way we push this clarification process. They say, well, this is kind of easy. Well, it can be a little bit harder. So here's a query for storage. This is a prototype application it's retail data, but it's all over the map. Lots of books, lots of electronics. It's a large, let's call it Fortune 5 retailers' data. And if you do a query for storage, it's not so much that it can say, aha, I have a value of storage here. It can say, look, I can tell that this set doesn't hold well together. It's actually, what it's doing here is it's actually piggybacking on the relevance ranking implicit on it and saying, when I do relevance ranking, the top results don't look like they are representative of the set of things that came back. Uh-oh. That means that either I have at least two working hypotheses. The set of results is a good one, or the relevance ranking knows better than the set of results and is actually pushing things the right direction. And so, when in doubt, do what Feynman would do. You just ask. And we say, aha, well, let's figure out what's special about that beginning set. And we look for the most information-bearing term in this case. Now we are using the tagging that's there. We say, aha, it's this category, toys, chest, and storage. While if we say, what makes the set most different from that? Well, it turns out it's computers. And just to be super careful that we're not relying on the metadata being so great, we show exemplar documents. And instead of just showing all the ways you could slice and dice this set, we promote these as saying, we're pretty sure that we don't know exactly what you want. So let's ask. Now, this may seem like this is what people do, right? If you don't understand someone, you ask, you reflect back to them what they said, and when you can, you propose meaningful directions. And by the way, when it's obvious what they said, you don't do that because then they get annoyed with you that it was a stupid answer. So this is in this HCIR spirit, having the machine try to be a bit more aware of the likely effectiveness of the communication. Now, the last point I want to use here is that people say, well, but how are you going to get the sorts of tagging? I'm not a sports buff, but I had the opportunity to work with a leading sports programming network based in New York that I'm not allowed to name on video. And I did hear about Roger Clemens, and I thought, let me look him up. Well, what you see on the left are the top, let's call them tags, values, what have you, associated with Clemens over all but the past year. What you see on the right are the tags associated with the more recent year. Now, for those of you who don't know, Roger Clemens, baseball player, was with the Yankees, probably took steroids, although that's still under investigation, and was featured in the Mitchell Report and fingered by his coach, Brian McNamee. Well, that's nice. This isn't necessarily telling me something I didn't know, but the point I'm after here is more where this data comes from. Turns out, okay, the names of players and of teams, everybody has that data. That's easy. But it turns out that the authors of sports-related articles are not necessarily tagging things the way that computer science graduate students hoping to get tenure someday do. So where are we going to get tags like Mitchell Report and Brian McNamee? From users. Now, this is something that I think folks here are probably quite familiar with. User logs are a pretty valuable source. So we crowdsourced the vocabulary from the user logs. Now, you might say that's a little bit dangerous. What if people start looking for porn all the time? But then we text mined against the data itself. So you couldn't get tagged unless you're actually about something. But we used the users to figure out what they were looking for, because what they were looking for is likely to be what their things are about, or at the very least, what they want. And again, put this in the service of ways to communicate what document sets are about, going a bit beyond, again, just returning ranked lists. And I'm sure you can find this online if you go through the leading sports programming network sites. Now, what we're after here is trying to trick the classic trade-off of information retrieval, which is that you have precision, which is how many of the documents returned are relevant. You have recall, which is of the documents you could have returned to a user that are relevant, which ones did you get? Now, I know this is a bit of a set retrieval-oriented way of thinking of it. For those who want ranked retrieval, you can think of mean average precision somewhere in this framework. But the point is this. It's like Soylent Green tells us. People can help. People can cheat this because you don't need to guess what's in people's heads. You can actually ask them. And perhaps for those who are deep in the bowels of IR, who have been taught really since the 80s that set retrieval isn't the way to go, you should be doing ranked retrieval. I'm here at a company that probably to almost everybody outside of this audience is thought of as ranking things, or people just take it for granted that ranking is the way to go. I hope you'll consider the possibility that ranking isn't always the way to go, because it's not actually communicative enough. That if you think in terms of retrieving sets, there's something you can do that ranking doesn't give you. At least you can do ranking as well. But with sets, there's a notion of summarizing them and giving people a more holistic, a more efficient and aggregated view of what all is out there, and then importantly, where you can go from there. Now, this isn't necessarily the only way to implement an HCIR approach. But frankly, I found that it's the most effective one, because you're basically taking that screen, that limited real estate. Just imagine on an iPhone instead of on a screen of this size, and trying to pack the most communication bandwidth for your buck into that interaction with the user. And you get to just 3 principles, right? If I can have the takeaways from this as to what I would say you can do with this. Right? HCIR is a nice idea, but how do you make it real? Well, you make it real by emphasizing set summaries over ranked lists. You make it real by, instead of making the interface be dominated by a minimal user input followed by lots of crunching on the machine side to try as hard as possible to get it exactly right. Don't optimize for getting it right in one query. Optimize for getting it right, period. That might not be good for casual users. I'll concede that. There are some people who will try one query. If they don't find it, they'll leave. But there are a lot of use cases. And I mean, I thought, well, my mom, she teaches Latin American literature. She won't relate to this at all. But it turns out she does. So when she's looking for things, often she's doing a dozen queries. Now, perhaps part of the great success that Google has achieved is that she blames herself and not Google for not finding something. That's impressive. And in fairness, it takes two. I sometimes look at her queries and am inclined to blame her too. But the thing is that a user's query is not the last query. There's a lot more you can do if you take a more dialogue-oriented approach. And then it's not just about finding what the user said he or she wanted right now. Exploration and discovery are not nice-to-haves. For many problems, they're must-haves because people don't know exactly what they want. And if they're not satisfied meeting their information needs, you can't go to them afterwards and say, hey, well, it's your own fault for not having figured out how to express that in a query. I mean, we're in the business of helping people find what they want. It's important to actually support a broader set of information needs than the easy ones, the ones that in many cases actually have Wikipedia pages that answer the questions. I mean, if Jimmy Wales can do that on $6.3 million and be 25 underpaid employees, we're not doing our jobs. And I think this is a bit redundant, but that's good because I'm running out of time. Support this interaction. It's true that lots of people like eating at McDonald's. But isn't it a good thing that people in some cases are more demanding than that? And I realize I'm provoking and only allowed to do that because I'm in control of the microphone. But Google has really solved the easy use cases really, really well. I'd be the first to admit that. But I think that there is a bit of reluctance to look at some of the harder ones. I'm not sure why, and perhaps when I'm pummeled with questions after this, I'll get more of a sense from you guys. And one more thing. Google's mission is to organize the world's information, right, and to make it universally accessible and useful. But I want to go on this organizing thing. The Alexandria Library was perhaps one of the first efforts to organize the world's information, right, to classify it, to put it in different places so that people could look for things. A lot of what we see now, specifically in web search, focuses on an adversarial model, where the most important thing turns out to be to take the competing people who are trying to get ranked at the top of lists for queries and somehow adjudicate that. That's, in fact, why in the earliest days, Google was able to basically trounce every game in town. And it wasn't just because of having a streamlined interface, and it wasn't just because of speed. It was because of relevance. And what relevance meant in that age was doing better than the spammers who were exploiting algorithms that folks like Lycos and AltaVista were using that were in many cases built on TF-IDF and its variants that could be easily gamed by spammers. The notion of using link analysis for authority is brilliant because, first, it's a good idea. But secondly, it was really hard to game. Now, that was then and this is now. And I know that there are lots of folks in Amit Singh's group who probably spend every waking hour discovering the ways that people fake link farms. I dabble in seeing when I can sort of Google bomb things myself. But let's even imagine that crew is doing it all right. But that's refereeing. It is not organizing. And I think that everyone, but especially folks here, should be embracing the vision that is actually in the statement of being more than just adjudicating between the competitors for ranking. With that, I'd like to thank you and open for questions.
I should observe that sorry, I missed the start of the talk there.
Okay, Mike.
That there might be another way of thinking about the success of Google, which was not just the getting there first, but also having a business model that actually kept it in business with real revenue early. So, which has nothing to do with how well search works.
That's a fair point, and it's actually it's funny, right? Because I'm sure a bunch of folks are familiar with the saga of GoTo, Overture, Yahoo, and eventually the settlement before the IPO. But I think that it's people who look there forget, you're right, that Google actually figured out how to take this notion of bidding for ads and make it something that people would actually use and not block. The questions?
Hey, Daniel, I think going here. I like the idea that when faced with ambiguity, we as humans really do give us choices between sets.
Mm-hmm.
Did you mean this? Do you want to know more about that? And with your human-computer interface, I think that's really interesting where you're going with this. I guess the question is, when you talk about the easy problem versus one that requires more of a set-based solution, how do you know the difference? How do you build a system that can tell the difference between one that really is, I'll just get a blank list, and one that really does require some disambiguation?
So let me just repeat the question, because I'm not, especially for the online audience, is how can you recognize when a query requires clarification? And what we did in that data-driven one, I think is instructive, which is that we looked at the results the user would see based on a ranking algorithm. And that ranking algorithm, we knew, had actually even had human input because it was reflective of someone familiar with the data. And we compared that to what would have happened if we had essentially ignored that relevance ranking algorithm and returned the whole set. The reason we actually did that comparison wasn't just to see what we could do with our hands behind our backs, but because we knew that we would be driving all the sorts of refinement behavior from that set, which is the common approach. When there was a divergence between that, and that we can quantify, we used a variation of relative entropy, or Kullback-Leibler divergence, to make that information gain. I think it's the final synonym there, to say, hey, those look different. Now you could say, well, what do we mean with those look different? Well, if we were to compress those sets, in that case we had the benefit of some metadata, but we could have generated that metadata as well, or even in an extreme case used kind of a bag of words representation. And we said, look, you would not be able, you said these would not look like the same query. Therefore, we can see that there's going to be ambiguity. Now there's a worst case where you can say, well, what if we didn't have relevance ranking at all? And that was actually where we started on this. We decided to be more conservative there. In that case, it's almost like the game of Jeopardy. You could say, I'm going to show you a set of results. Now you have to come up with a query. Now I'm not going to show you a whole set of results because that's a lot. Maybe I'll just show you a random subset. Maybe I'll show you top 10 by some sorting. The point I'm after is that the compressibility of a set is actually reflective of how efficiently it's communicating to you. The work there is actually inspired by some stuff done also at the University of Massachusetts on query clarity. And they were looking at it in a slightly different way that was more query-centric. But we realized you could actually look at the result sets themselves, and you could think of it as, could I succeed in the game of Jeopardy? If you saw my results, could you reproduce what I had gotten as a human being?
So I'm thinking of a case where you have an ambiguous query and you can show different data sets like storage. You can show, furniture. You can show computer storage, right? It seems like in order to do this, you have to cluster so you have to find all the documents related to storage, for example, if you don't have them categorized, right? And then you have to cluster documents with respect to the query. You can't really pre-cluster.
No, so
How come essentially intensive for this?
okay, so the question is basically, it's a computational question, which is that if you have to do this kind of disambiguation at runtime, then how are you going to do this? Like in the query for storage, we first had to get those results. Then we had to somehow look at them, recognize that it was ambiguous, and so forth. So the first answer is, yes, you have to perform an analysis on those results. And in particular, I'll volunteer that it's not the sort of analysis that would be easy to do if your only access to the data was by means of an inverted index where you can look up storage. You have to actually be able to look at the documents and gather information from them in order to then decide that you even have ambiguity in the first place. So it's a good idea to store the information that you're going to need to do that in a way that you can rapidly go through it on the documents. The good news, however, is that you don't necessarily have to look at every single document to recognize that your result set is bad. I mean, human beings aren't going to do that either. So you very quickly develop a statistically significant intuition, if you will, that something is wrong. So on one hand, you do need to have the data close by so that you can see it. But the amount of data that you have to look at to recognize the problem is not so bad. Once you've recognized that this is going on, actually coming up with the alternatives isn't so bad, because then you're in a position where it turns out your inverted access is more helpful. Now, perhaps one thing that is important here, I didn't sign the thing that lets me find out how all of Google's indexes are stored, but I have the suspicion that there is a favoring for as the only ranking algorithm that is allowed on the web. I'm not allowed to re-rank my results by clicking a different sort. Now, that is a bit of a problem, because in order to, when we do this kind of disambiguation, we don't necessarily want to be top-heavy on all of the top-ranked results. It's important to have some ability to do random access there, so that that's not so much necessarily a computational overhead. It's a data structure choice that you have to make.
So one of the things I was hoping you would do in this, which I clearly didn't do in sort of a particular direction, is think about sort of other dimensions of search. So, this was sort of all about searching text documents at a fundamental level. And the kinds of things that I sort of would love to be able to search are, I have a picture of somebody. Who the hell is it? I have a picture of a building or of a thing, a piece of art or an object. I mean, the typical thing is I find a piece of plastic, right, on the floor in my house. Now, either it's a piece of junk that my kid left around that I can safely throw away, or it is, in fact, a crucial piece of something that in 6 months' time I will discover that I wish to hell I hadn't thrown away. I'd love to be able to take the thing in front of my camera and go click and say, what is this? Okay. So where is that in all of this universe?
So the question is, where are things like image search by example? Like I take a picture of something and search for it. Where does that fit into this HCIR framework? And it's orthogonal to a point, which is to say the problem of figuring out from that picture, for example, that becomes our query. Let's assume that you input it as a picture, and then your relevance algorithm is some kind of image similarity. And I'm not an image IR guy, but I know a company called Modista, for example, and there are various others. I know Google's been doing some work on that as well. That can give you a set of plausible alternatives. Now, if the set of plausible alternatives, there are a couple of things. If the algorithms are not very good, you can run into some problems. If the algorithms are great and your query is unambiguous, this becomes an easy query. And it's just that, you just have to make better algorithms. The place where this comes into play is when the set of things that could be relevant to your query is actually sizable. So to take an example that's maybe a little bit afield, look at the ESP game, right, or which is now used for Google image labels. That finding an image from a description is actually somewhat challenging. Honestly, when I use Google image search, which in fact helped a lot for finding the variety of the pictures you see here, which I want to say are credited in the presentation itself, it actually helped a lot to use the most recently released feature that I could at least see what was clip art or what was photo, and so forth. That was very helpful. That was a step in that direction. It would have been nicer to see other kinds of organization, because even if I'm not great at describing a picture, being given a little bit of help to elaborate the query would help. Now, you could say, well, but who needs that if I just have the picture there and can search for it? Well, if it's like chess. If once the machine gets good enough at just doing the matching, if it's as simple as that, all done. I point at this startup Modista, and yes, no, free product placement for them, because they're looking at how to find shoes. And it turns out that just because you know that you like one shoe doesn't mean that that's exactly the shoe you're going to buy. Among other things, it's probably too expensive, and so you want to explore the related space. I think that's closer to a use case that you're describing. But the input is not necessarily that you scan in a picture. They're presuming that you're looking around and probably clicking on one. But arguably, that's just an implementation detail.
You speak a lot about disambiguation of very large sets of data where you just have too much information to be verified or refined or drilled into. But is there any work being done when you enter a very specific query to know exactly what you want and there's very few results, or they're just awful? What kind of work is being done in that area?
So the question is let's look at the other side of the disambiguation problem, which is not so much overly vague queries as overly specific ones. Well, you could actually look at that Steve Pollitt example as a case of it, where it's a bit after the fact, when I discovered that I was more generally interested in what people are doing in refinement and information retrieval once I was there. So another way of thinking about that is how there are several things. One is, if I find a document, what context should I look at it in? And I think the biggest part of that problem is, how should I annotate that document in a way that plays well with the rest of the corpus? Most of the work I've seen on annotation is very document-centric, rather than saying, give me a vocabulary that will be helpful to the corpus as a whole. That was actually something that we paid a lot of attention to in the work we did with the ACM, because actually turned out authors had that problem. That's one version of it. The other version can be your query itself is overly specific, and as a result, you're getting to bad documents. Well, a hopeful case is we can recognize that the result set is bad, because it's, for its size anyway, either it's really small, maybe we decide small sets are bad, or small sets unless they match the query exactly. You can pick your heuristics for this. But more, if the sets are actually a little bit larger, their lack of coherence is usually a good signal that something is wrong. Well, the thing is, we didn't just, when we got back the set of results, presumably we did, a conjunctive search, the intersection of every query term, but maybe expanding for stemming, thesauri. There's nothing that said we had to do it that way. We could have dropped a few terms. We could have searched different indices. There are lots of things that we could have done to interpret the query. So then you can step back and say, well, maybe we should have. And you can see if a different query interpretation would have gotten you to a better result set. Now, I believe one of the earlier questions was about what's the computational intensiveness of this. And it becomes a search problem in the AI sense of search. That is, if you have lots of ways you could process your query, which way should you do it? You can certainly get into trouble there computationally. But you can work as hard as you feel you need to. Hopefully most people aren't asking hard questions or dumb questions like my immediate family, so that you can process their queries easily and divert the rest of your service to the harder ones. There are ways to do that. So those are your two, as far as I can tell, two approaches. One is see if you can process the query differently, and the other is the query is fine. See if you can provide more context to the results that come back.
Can this sort of back and forth stuff be applied to the type of hard questions you showed at the beginning? The give me a book to read on the beach, or an algorithm for partial sorting?
So the book on the beach, certainly, right? Part of it is going to be, so an example where we worked with one of our clients. We started from a fairly simple, collaborative filtering style interface, where it would show you all of the books that people with your book purchasing history liked. But then we said, well, but we're going to offer a faceted search on top of that. So what's nice here is that, let's say you liked Michael Lewis's Moneyball. Now, some people might like it. So Michael Lewis, the Liar's Poker guy, fun author. I think he just came out with a new book as well. Moneyball is about the statistical science of baseball. Now, what's fun about that book, from my perspective, is that you're either interested in it because you're interested in statistics or you're interested in baseball. Maybe there's even a rare set of people who care about both. But the point is, I don't want to be sent a whole bunch of baseball books, in my own case, just because I like Moneyball. And I'm sure the baseball aficionados feel the opposite way. So offering the ability to explore that space in a faceted search interface on top of collaborative filtering is one way. The other way is what I like to call social navigation, which is, again, instead of looking at recommendations through the sort of black box of saying, well, this is what people who liked my stuff liked, actually think of navigating the space of demographics, if you will. I want to know, if I'm buying a book, I'm buying it for, say, my mother-in-law. And what do I know about her? She is in her mid-60s. I hope I don't get in trouble for this. And is female, lives in California, et cetera. What do those people like? So I can actually think of the lens itself as a means of navigating. And we have something like that, actually, if you look at Fandango, for looking at movie reviews, exploring that space by the view. It's only, say, a small step in that direction, but it's in the spirit of that. The partial ordering one, I'll give you guys a hint. It's not going to be very efficient.
We've run out of our time. I'm sure if you'd like to come up and chat some more with Dan, he'll stick around for a little while. In the meantime, thank you all very much for coming, and thank you very much for a fascinating talk.
Thank you, Mark, for hosting. Thank you.